Okay, good day, class, and welcome back to my pre-calculus section. So, I will be looking at conic sections, that is, just looking at some sections of cone when we intersect the maples of cones a plane, with a plane. So, if you look at this, we are intersecting the face of this cone with this plane. And what you observe is that we have this shape that we call parabola. If we intersect the markers at 90 degrees, then we have a circle. If we intersect the sides, that is here and here, at an angle, then what we have is ellipse. And if we intersect the faces of the cone, the faces vertically with that plane, then we have what we call hyperbola. Well, we'll be looking at this one after the other. Let me. So let us start. Right. Okay. This is. I need to clean this. Oh my gosh. Okay. All right. Now, let us look into circle. So we'll start with circle that you might be familiar with. So generally, the equation of a circle is given by this: x minus h squared plus y minus k squared equals to r squared, where h comma k is the center of the circle and r is the radius of the circle. If the circle is centered at the origin, that is, h is 0, k is 0, then we have x squared plus y squared as the equation of the circle. Well, let us take example with circle. So in this case, this is telling us that we are having a circle centered at the origin, because if we compare that to what we have as the equation of the circle, y minus k squared equals to r squared. If you compare that, you will see that we do not have h, meaning it is 0. Here it is 0. So it is centered at the origin. And the radius, look at this, r squared is 4, meaning that r is plus or minus 2. So all what you need to do is to come to the center. You count to the right, 1, 2, then make a point. You come to the center, go up, 1, 2, come to the center again, 1, 2, the here, 1, 2, then you can draw your circle. So we have something like that. Now, what if the circle is centered at something different from 0, 0, that is not at the origin? Okay. We will do the same thing. So we locate the center. The center of the circle is at 3, negative 2. So that is at this point, this is where we have the center. And our radius is 5, meaning I need to count 5. 1, 2, 3, 4, 5. I have it here. 1, 2, 3, 4, 5. So I have it. Let me 1, 2, 3, 4, 5. Yes. So here 1, 2, 3, 4, 5. I have this. Then to the left here 1, 2, 3, 4, 5. I have this. Then I can draw my circle. So I can draw my circle. So that is a circle with a center 3, negative 2 and radius 5. If I ask you to write equation of this circle. So remember that you only need to use this formula, y minus h all squared plus y minus k all squared equals to r squared. And in this case, this is our h and this is our k. So we just have x minus 3 all squared plus y minus, now k is -2, so that becomes +2 squared equals to, our radius is 5, so r squared is 25. So if you just put this in decimals, you will have exactly what we have here. So that is that. Circle is pretty, um, you know, easy to deal with. Okay, let us keep going. Let us keep going. All right, draw the graph of the circle. Now, in this case, you would see that this equation is actually not in the standard form. By standard form, I mean this form. Sorry, I mean this form minus h all squared for circle plus y minus k all squared equals to r squared. If you look at what we have here, it is not in that form. So we cannot talk about the center or the radius of this circle for now. So we need to complete the square in order to be able to write it in this form. So to do that, let me quickly show you. X squared plus y squared minus 8x plus 6y plus 21 equals to 0. So what we need to do is to complete the square. This is interesting. Okay, I can manage it. So to do that, I just need to bring all the x's together. X squared minus 8x, then plus y squared plus 6y plus 21 equals to 0. So to complete this square, I can say x squared minus 8x plus, I'm going to add some quantity there. So plus y squared plus 6y plus, then I'm going to add some quantity here to complete that square, plus 21 equals to 0. So to do this, I'm going to ask, what is the half of this coefficient of x? It is -8. So half of -8 is -4. Then I'm going to square it. I will do the same thing here. What is the half of the coefficient of y? Coefficient of y is 6. Half of that is +3. So I'm going to square that as well. However, remember that I am adding some stuff here. I have created imbalance. Where did they come from? So I need to add that same quantity to the right-hand side to maintain balance. So here I'm adding 16, so I need to add it here. And on this point, I'm adding 9, so I need to add it here. So now this 3 becomes something like this. X, I'm using the sign here, minus 4 all squared is the same thing as this whole thing here. If you want to check, you can just quickly expand this, which is x minus 4 times x minus 4. And that is x squared minus 4x minus 4x plus 16. So that is x squared minus 8x plus 16, which is exactly what we have here. So the same thing work with that. So that is y plus 3 all squared equals to, this is 25 Then you can bring this to the other side. So that is minus 21, 25 minus 21. And that implies that we have x minus 4 all squared plus y plus 3 all squared equals to 4. And as you can see, we can now talk about the center and the radius. So in that case, our center, h comma k, is 4 comma negative 3. Since here is positive 3, so k will be negative 3, and the radius is 2, right? Because r squared is 4, so radius is 2. So with that, I just need to go to the graph for negative 3 here. So from this point, I count 2 to the right, I count 2 downward, I count 2 upward, I count 2 sideways to the left. So I have this cycle. So that is that. That is that. It is as simple as that. So the main thing we did here is just this idea that we need to complete the square so that we will be able to write that equation in the standard form. Okay, moving on. Now let us study ellipses. Let us study ellipses. Now, from what I showed you from the beginning, ellipses, we obtain ellipses when we intersect the nappers of a cone with a plane at an angle. So, in this case, we can obtain an ellipse by, this pin, just pinning 2 points, and then you can put a thread on these 2 points, at these 2 points. Then you extend that out using a pencil and you trace out, just like we have in this case. Then you trace it out. The shape you're going to have is going to be something like this, an oval. And we will have this situation if we draw it out. Now, those 2 points where you put the pins, we call them foci, singular focus. So call it foci. Now, you would see that here it appears that this is the longer part. Some people will say a circle is stretched. So in this case, it seems like it is stretched along x-axis. So wherever we have the stretched part, that is where we have the focus, okay, or the foci. And that is where we have the vertices. The vertices. The other two ends, that is where we have the co-vertices. Okay? And now the longer part is the major axis, and the shorter part is the minor axis. Okay, so that is just basically what I was explaining using all of this. All of this. Then we can talk about the center. Now, what I want to do is just to show you briefly the general form of equation of an ellipse. So let us see how that comes into reality. Now, breaking what I showed you the other time down, I want to say, oh, there is one important thing I need to mention to you. An ellipse, an ellipse is a set of all points in a plane such that the sum of their distances from two fixed points is a constant. What does that mean? Let me quickly show you that. So we are saying that from these two fixed points, this point and this point. So let's say from ear to ear, we call it D1, distance 1. Ear to ear, we call it D2, distance 2. The claim is that if you add those two distances, that is D1 plus D2, let's say I pick this. Let me use another pen. Uh, okay, this. Okay, so suppose this is where I am now. And let's say I call this A1 and this A2. Then what I'm saying is that if I add A1 to A2, it is going to be exactly the same as D1 and D plus D2. So that is what we mean by it is a constant. That is, if I also do this, maybe something like this from ear to ear, from ear to ear, and I add those two lengths together. If I call this C1, C2, it will still be, the sum will still be the same as this. So that is what we mean by the sum of the distance from the fixed point is a constant. That is what we mean by that. We will need that in our proof. Now, again, we know that if we just call this a point, a point in the plane, we call it x comma y. So this point, we call it a comma 0. Remember, let me show you again. Oh my. Okay. So let me show you again. Okay, this. Uh, okay, no problem. Let me just continue with it. So I call this point a comma 0. That is the distance from this point, this center, all the way to this point. I call it a. Then the distance from this center to this vertex, I call it negative a. If I ask you, what is the length of the major axis? That is from this end all the way to this end. You know, that will be 2a, the length of everything. Okay. Now, that is that. Again, we also have this point, that is our focus here. We label it negative c to 0, comma 0. Remember, because our focus is on, or it is along x-axis. So that is why we are having x, we are having x. Okay. Then I call the distance from ear to ear D1, the distance from ear to ear D2. Now I need all of this. So suppose I say that D1 plus D2 is a constant. Let me first figure out what D1 plus D2 is. You would also see that if let me change my pen so that you see it very well. If I say from here to this point, and from here to this point, you agree with me that it is two-way, which is exactly, remember how we define D1 plus D2, right? It is a constant. So I'm picking this fixed point, this fixed point. So I say from here to here, then from here all the way to this place. It is two-way. I hope that makes sense. Or you look at it this way, from here to this point, right? Then from this point all the way to this point, right? It's 2a. So my claim is that d1 plus d2 is 2a. Let us see if we can use this idea to figure out something. What is d1? That is distance from x comma y to negative c comma 0. Well, let us use distance between 2 points. The formula for distance between these 2 points, d1 is the square root of x, this x minus this x point minus c all squared plus y minus the other point, y squared. So if we do not know, let me write it here. Suppose we have x1 comma y1 and x2 comma y2. Suppose these are 2 points. Then distance, the distance between the 2 points, is given as square root of, we can say, maybe x2 minus x1 all squared plus y2 minus y1 all squared. So that is what I'm trying to do here. So d1 is, so let's say this is, so if I am saying this is maybe this is x1, it doesn't matter, x2 y1 y2, so I'm saying x2 minus x1, so that is what I do here, x minus c plus the same thing here. So now I will do the same thing for d2. So here becomes plus x plus c all squared plus y. So this is x plus c all squared plus y squared. That is d1. d2, I will do the same thing, and I have square root of, say, x. So I'm using this point and this point now. So that is x minus c all squared plus y minus 0 all squared. So that is square root of x minus c all squared plus y squared. So that is the truth. Now remember that, so at this point, let me see if I have space here or I can use whiteboard. Okay, let me use whiteboard. Okay, stop sharing this whiteboard. Okay, so d1 plus d2 equals to 2a. You remember this? Now, our d1 is square root of x plus c all squared plus y squared. That is d1 plus d2 is square root of x minus c all squared plus y squared equals to 2a. Let me cross-check to be sure that is what I... okay, interesting. Okay. Now, all right. Now let us solve this. Let us solve this. Okay, I can do something. I can move this to the other side. So I have my whole goal is to get rid of the square root. So that is my goal. Squared plus y squared equals to 2a minus square root of x minus c all squared plus y squared. So I can square both sides. So that means here I will have x plus c all squared plus y squared. This square will get rid of the square root equals to. However, here I cannot do that. I need to, it's as if I'm having x minus a all squared. So I need to expand that. Okay, so that is 4a squared minus 4a times square root of x minus c all squared plus y squared plus, now square root of this, I'm squaring it. So I will have negative square, that is positive. So if I square that, I will have x minus c all squared plus y squared. If I expand this, I will have x squared plus 2xc plus c squared plus y squared. This is the whole of this. So plus y squared equals to 4a squared minus 4a times square root of x minus c all squared plus y squared. Then I can also expand this. This is x squared minus 2xc plus c squared plus y squared. I can get rid of some things. Let's see. I can get rid of, this is x squared, this is x squared, that goes. This is c squared, this is c squared. They have the same sign. That's why I can say, because if you move c squared to the other side, it becomes minus, so it gets rid of that. The same thing with y squared, y squared. So what do I have left? You see, I cannot do that for 2xc because this is negative, this is positive. If I move it to the other side, it becomes positive. So now I have 2xc equals to 4a squared minus 4a squared root of x minus c all squared plus y squared plus, sorry, minus 2xc. So I can move 2xc to the other side. So that is 4xc equals to 4a squared minus 4a square root of x minus c squared plus y squared. I can divide all through by 4 since 4 is common to each term. So that is xc equals to a squared minus a times square root of x minus c squared plus y squared. So yeah, I divide through by 4. Okay, what next? Can we do? We can move this to the other side. Why? I want to get rid of the square roots over there. So that is xc minus a squared equals to negative a square root of x minus c all squared plus y squared. Now I can square both sides. So squaring both sides. The goal is to get rid of the square root. That's what we are working towards. So we do the same thing here. We have x squared, c squared, minus 2a squared xc plus a raised to power 4 equals to, if I square negative a, it becomes positive a squared. So if I square this gets rid of that. So I need to be careful here. So that a squared is multiplying everything. So d squared plus y squared. So I have x squared c squared minus 2a squared xc plus 2a raised to power 4. Oh no, where did I see that? So plus a raised to power 4 equals to a squared. I can open up this, that is x squared minus 2xc plus c squared plus y squared. I can open up with a squared, so that is a squared x squared minus 2a squared xc plus a squared c squared plus a squared y squared. And I just copy and paste what I have here. Now, looking at this, I can get rid of this. Again, they have the same sign. So if I move this to the other side, it becomes plus. So it goes away. So I can do that. What else can I do? So nothing goes off again. So I can, let's see. I want to write everything here now. I want to write it here. So a squared x squared plus a squared c squared plus a squared y squared. And it is equal to x squared c squared plus a raised to power 4. It's the same thing. We've not done anything illegal mathematically. So I can bring all the x's together. So I have a squared x squared minus x squared c squared. Let me put this with it, the one with y. Then I have a raised to power 4 here. Then I will move this guy to the other side. This one, I move it to the other side. If I factor x squared out, I have x squared into a squared minus c squared plus a squared y squared equals to, I can factor a squared out, then I have a squared minus c squared. I can do something. Let's b squared stand for a squared minus c squared. So I want to represent that. Then I can say this is x squared b squared plus a squared y squared equals to a squared, then this, using my representation, b squared. Now, I can divide out through by this term. So I have, let me change this. So I can just divide through by a squared b squared, a squared b squared, a squared b squared. So what I did there, I just divide through by a squared b squared. So here I have 1. Now this will take care of this. So I have y squared over b squared plus this will take care of this. So I have x squared over a squared equals to 1. And then we say this is the equation of an ellipse, the standard equation of an ellipse. And so the proof is quite long. That is why I did not do it in class and just put it in video so that you can just learn it for your knowledge. Okay. Um, so this is all about this. And here we are making the assumption that A is greater than B. Um, the ellipse, the ellipse, as you saw from our starting point, the ellipse is centered. The ellipse is centered at 0, 0. Then we say A, B, and C are related by this expression or equation. So which is I can actually call it, let me rewrite this. I can write this as C squared equals to A squared minus B squared. I can write it as that. Just move this to the other side and move this to this side. So I want AB to be together. So C squared equals to A squared minus B squared. So all of these will be very important in our um, subsequent work. So I hope this makes sense to you. If not, just take your time to work it out just for your personal consumption. Uh, okay. All right. Let me go back to my notes here. Okay. Now, we're back to this note. Now, from what we just did, we see that the equation of an ellipse is given by this equation. And like I've said, with this idea that A is bigger than B, and so where A is greater than B, the length of the major axis is 2A. We have seen that already. Now, the coordinates of the vertices. Now, I'm going to differentiate between vertices and co-vertices. Vertices will always be where we have the ellipse stretched, right? So you will see from this, we have it stretched along x-axis. So I will say this is negative A, this is A, comma 0. So that is why it is along the x coordinates. Now the other side, this is B, and this is negative B. Oh, sorry, that is 0, comma negative B, and this is 0, comma B. So this, I call them co-vertices. Co-vertices, this point and this point, right? And you will see it is along Y. And like I've said, like I've shown you, we can relate C, A, and B using this equation. Now, a couple of things. A, which is always that always stand for vertices. Anywhere you see A, it tells us a story of which axis is having the major axis. That is, which axis is the major axis. That is what is pointing you to. So this is A, then it means our major axis is along X. In this case, look at another version of the equation, this. So you will see my A is under Y. That is to tell you that the major axis is along Y. Okay. Um, Another thing we should know is that you will always have the vertices on the major axis, and you will always have the focus on the major axis. So please take note of that. Just like here, this is the major axis here. So we have the vertices there. Remember, A represent the vertices. And then we also have the focus on major axis. Okay, we can move on. We can move on now. So let us move on to example. What is the standard form equation of the ellipse that has vertices? This, look at it. My vertices are along x component. That tells you that this equation is what is going to represent my situation. A will always tell the story of, you know, where I have my major axis. So now A squared is, so this is A. So A squared is going to be 64. Um, I don't have B, but I have C, foci. So C squared is 5 raised to power 2, that is 25. However, remember that we can do C squared equals to A squared minus B squared. So which means 25 equals to 64 minus B squared. And that implies that B squared equals to 39. I'm bringing everything together from here. So we have x squared over our A squared is 64 plus y squared over our B squared is 39. So 39 equals to 1. So this is the equation of the ellipse in standard form. Okay, moving on. So you can pause this video and just solve this. Pause the video and solve this. Pause the video and solve this. Uh, yeah. In the end, you should be able to write something of this form. But take note, your vertices is along y. So you should be having something like x squared over b squared plus y squared over a squared equals to 1. So find, you have a squared, so find b squared, you have c squared. So, I mean, you have c, so find c squared. You have find a squared, then using that, you can find b squared, and you put everything together, just like we did earlier. Okay, let us go on to example 2. Example 2. Graph the ellipse given by the equation. Okay, let us see. Graph the ellipse given by this equation. There is a story this equation is telling. We have 25, which is bigger. Remember, A is always bigger than B. So we have 25 under Y. So we say 25 is greater than 9. That tells us that major axis is along, major axis is along Y. Okay, now So that means we know what a squared is. A squared is 25. So definitely b squared is 9. So we can find c from that. So c squared is a squared minus b squared, which is 25 minus 9, and that is 16. So that is c squared, which implies that c is plus or minus 4. Now, what does that help us to find? Now we know the vertices. The vertices will be, remember, it is along y. So that is 0, comma. So a squared is 25. So a is going to be plus or minus 5. Remember, vertices is giving us 0, comma, plus or minus a. So, okay. Um, co-vertices, 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 that is your B, which is along X. So that is plus or minus 3, comma, 0. Your foci is always along the major axis, where you have the major axis. In this case, it is Y. So that is 0, comma, plus or minus 4. See, so we can now graph our ellipse. So the vertices 0, y is negative 5 here, positive 5 here. Then co-vertices, so you can label this 0, comma 5, that is vertex singular. So this is 0, comma negative 5. This is vertex. So co-vertices, we have when x is 3, y is 0. When x is negative 3, y is 0. So negative 3, comma 0, 3, comma 0. So co-vertex. Now we can graph ellipse, something like that. Okay, and our center, remember, is 0, 0. So yeah, origin 0, 0 there. Well, minor axis and major axis. Oops. So here is minor, and this is major axis. Now, that is our ellipse for this situation. I hope this makes sense to you. Oh, one more thing that we cannot leave out is the focus. So we have one at 0, 0,4, 0, 0,4, and 0, negative 4. So that is focus, focus. Okay. Uh, yeah, I need to take care of this. All right, let us move on to another example. So you can pause this video and try to work on this review problem. Pause it. I will solve this for you. 4x squared plus 25y squared equals to 100. It is an ellipse. We are told that it's an ellipse. Grab the ellipse given by the equation. Now, remember, equation of my ellipse should be in this form. at least. This is one form. This part is always 1. However, what I'm having here is 100, 100. So I can divide all through by 100. Remember, I need to do that for each term. So let's see if that helps. Let's see if that helps. So I will have x squared over 25 plus y squared over 4 equals to 1. Oh, yes, sweet. Again, this represents, or this tells us that the center is 0, 0. Okay. Well, you see 25 is bigger than 4. It means a squared is 25. Then b squared is 4. And that means that major axis is along x. With that being said, we can find c. So c squared is a squared minus b squared. So which is 25 minus 4. So which is 21. So c equals to square root of 21. So plus or minus square root of 21. So now we can find our vertices. So which is, since the major axis is along x, so our vertices also will be along x. So that is, and remember, A is the guy standing in for vertices. So that is plus or minus 5, right? Since a squared is 25, so a is plus or minus 5, comma 0. Co-vertices, definitely that will be along y. So that is 0, comma this. So that is plus or minus 2. Then the foci, which is c, always along the major axis, which is again x. So that is 0, comma plus or minus square root of 21. So now that we have these three guys, we can draw our ellipse. So the center again is at 0, comma 0. Vertices 5, 0 here, negative 5, 0. So we have our major axis there. Co-vertices 0, negative 2, 0, positive 2. So our ellipse looks like this. I missed that point. Okay, so this is my major axis, and this is my minor axis. So here, I would say this is vertex, vertex, co-vertex, co-vertex. This is center. Now, the foci. So that is 0. Well, plus or minus square root of 21. A very good way to quantify this is, I know that square root of 16 is 4, and the square root of 25 is 5, meaning that square root of 21 is going to be between square root of 16 and square root of 25, which is 4. So I should be having something like this. So it is between 4 and 5. So, which means I can say that 0, 0, 4, something like this, then 0, something like this. So that is my focus. So That is that, guys. There is nothing fancy here. The only thing new that we did was just this, rewriting that situation. I hope this makes sense to you. All right, moving forward. Um, Now you can pause the video and try to do this. Grab the ellipse given by this equation. Again, do the same thing we did the other time. That will be fine. Now, next up is to do the same thing we did with circle. That is, consider when it is not centered at 0. So we have some center, h comma k. So again, this is the x component, this is the y component. So we have x minus h squared divided by a squared plus y minus k all squared divided by b squared equals to 1. Again, this A is telling a story. It's telling us that the major axis is along X and the minor axis is along Y because A is still more than B. So if we have this case, it means our major axis is along Y. Okay. All right. Now, from this standard equation, so this is the standard equation for when the center is h comma k. For these standard equations, we can easily determine the center, yes, the vertices, the co-vertices, the foci, and positions of major and minor axes. All what you need to do is simple. Let me show you briefly. So, this is what you need to do. Now, remember that the other time we claimed that vertices will be, in this case, let us consider this case. In this case, where we have it along x-axis. So we say it is plus or minus a, comma 0, co-vertices, co-vertices, co-vertices is along y now in that situation. And our foci will be along x as well. Now, when the center is not 0, when it is h comma k, what we need to do is to account for that. So center is h comma k. Remember, just like we did with circle, when we add center, so everything starts from the center. So the same thing we apply here. So I just need to account for that. And that transforms these three guys into this. So vertices, I just need to start with h, comma, k. So I need to account for that. So h, comma, k. Now, remember that because my vertices is along x, so I just come here and say plus or minus a. So this is my, this will be my vertices when I have center h comma k. So co-vertices, same thing. Co-vertices in this case, where it is along y. So again, I will start from h comma k. So since it's along y, I will just add plus or minus b. The same thing with focus or foci. So h comma, K. Again, since my major axis is along X, so my focus will be there. That is plus or minus C. So that is everything I have here. Everything I have here. Okay, so let us take an example to explain this situation. Let us take an example to explain this situation. All right. Graph the ellipse given by the equation. Well, x plus 2 all squared divided by 4 plus y minus 5. This is in standard form. All squared equals to 1. There is a center. So let us start with that. Center, h comma k, is, now be careful here, this is x plus 2. Remember, it has to be x minus h all squared. So meaning that we can write this as x minus minus 2 squared. So it means our h is negative 2. So minus 2. Then this part is in the right way. So that is 5. So that is our center. That is the center. Now, there is a story this equation is telling. It is telling us that since 9, let me write it that way. So I know that since 9 is bigger than 4, it means that major axis is along y. And that means that a squared is 9 and b squared is 4. We can find c. So using this, c squared is a squared minus b squared. So which is 9 minus 4, so which is 5. Therefore, c is plus or minus square root of 5. Now, what we do now is to find vertices, because those are the things we need. Co-vertices, and foci. So, vertices. Remember, like I said, we have to start from the center. You always account for the center. Now, for the vertices, we go to A. So this A squared is 9, so meaning A is plus or minus 3. And since major axis is along Y, so we have plus or minus 3. So the same thing, co-vertices will be along X. So that is, again, we start negative 2, comma, we start with the center. So we just account for that center. So plus or minus, our b is 2, since b squared is 4, so 2. So focus, that will be along major axis as well. However, we still need to start with the center. And since that is along y, so that is plus or minus square root of 5. So, which means vertices will be negative 2, 8 and negative 2, 2. Just using plus or minus we have here. Co-vertices will be minus 2 plus 2, 0, 5, and minus 2, that is minus 4, comma 5. Cosine, uh, so that is minus 2, comma 5 plus square root of 5. I will not worry myself too much on that. And minus 2, comma 5 minus square root of 5. So let us plot our graph. Vertices, negative 2, comma 8. That is when x is negative 2, y is 8, positive 8. So here, vertex. And the other one is negative 2, comma 2, negative 2, comma 2. So vertex. Co-vertex, 0, 5. When x is 0, y is 5. And when x is negative 4, y is 5. So I have this. Definitely here will be the center. Let's see. What is the center? Minus 2, 5. Minus 2, 5. See that? So, okay. Yeah, we have our ellipse that way. Okay, so do this and I can do this. So I have co-vertex, co-vertex. This is my center. This is my major axis, and this is my minor. So, guys, the last thing we do is the focus, foci. So, when x is negative 2, y is 5 plus square root of 5. Again, let's do the same thing. Square root of 5 should be between square root of 4 and the square root of 9. So that will be between 2 and 3. So, well, that is I'm adding something that is more than 2 to 5. So that would be more than 7, less than 8, right? So negative 2, comma, between 7 and 8. Let me use another pen so that you can see it. So somewhere here. And then negative 2, comma, from 5, I'm subtracting something that is more than 2. So that means it will be somewhere here. So that is what is that? So that is focus. Focus. So guys, that is all about graphing ellipses. I hope that makes sense. So we're able to identify and label the center, the vertices, the co-vertices, and the foci. We were able to do that. So again, let me get rid of this so that I can move forward. All right. So okay, let me solve this last one, then I will leave this for you as try it. So you can do that. But let me solve this. In class, we'll solve this together, but let me solve it in this video. This 4x squared plus 9y squared plus 40x plus 36y plus 100 equals to 0. Now, this is a case where we do not have it in standard form. Remember, our standard form is like this. A squared plus y minus k all squared over b squared equals to 1. We don't have it in this form. So let us try to rewrite just like we did with circle. So 4x squared plus 40x plus 9y squared plus 36y plus 100 equals to 0. Now, this is what I'm going to do. Like I said the other time, you want to be sure that the coefficient of x squared is 1. But in this case, it is not 1. It is 4. So you want to make sure you factor that 4 out. So I have x squared plus 10x plus, same thing here, 9 into y squared plus 4y. How is that 4? 9 times 2, 18 is 6. Okay, yeah. Plus 100 equals to 0. So I can complete the square here. So I have 4 into x squared plus 10x plus, I will add some quantity, plus 9 into y squared plus, oh, there is some, well, what did I do? Yeah, there is a y here. Okay, so plus 4y plus, I add some quantity there, plus 100 equals to 0. Now, what quantity am I adding? Where I ask. This is minus 40. Why did I write plus? See, this is minus 40. So that should be minus here. Okay. So here is minus as well. So half of that coefficient, which is negative 10, half of that is negative 5. So minus 5. Then I square it. The coefficient of y is positive 4. Half of that is positive 2. Then I square it. However, I have added so much to the left-hand side. I need to add that same thing to the right-hand side. Now, the question is, what am I adding here? I'm adding 25 in 4 places. Remember? So I'm going to add 100 here. The same thing, I'm adding 4. 2 raised to power 2 is 4 in 9 places. So that is 36. So I will have that. And now I have 4 into x minus 5 all squared plus 9 into y plus 2 all squared equals to, I can move this 100 to the other side. So that will be 136 minus 100, that is 36. Now we can say, well, we want the other side to be 1, so we can divide through by 36. Can divide through by 36, and we would have x minus 5 all squared over 9 plus y plus 2 all squared over 4 equals to 1. So now we have it. We have it in the form we want. Now, what next? We can now start our work. So, center. The center is, here we can see h is 5 and k is negative 2, right? We can say since 9 is more than 4, major axis is along x in this case. Now, uh, so which means a squared is 9, b squared is 4. So let us find c using this relation. C squared equals to a squared minus b squared. So which is 9 minus 4, and that is 5. So c equals to plus or minus square root of 5. Okay? All right. So I need to get rid of this so that I can move on. I'm using PDF, that's why Zoom is not allowing me to. Let me do that. Okay, so I can move my work. Now, what do I need more? Now I have the center. I can now write my vertices. Vertices. Now remember, the first thing we need to account for is the center, which is 5, comma 2. So 5, comma, negative 2. Now, from the equation we have the other time, we know that, okay, let me write it here, x minus 5 all squared over 9, I believe, plus y plus 2 squared over 4 equals to 1. So our center is 5, comma negative 2. A is plus or minus 3, so I just need to do that here, plus or minus 3, since it is along x. Now, that implies that our vertices will be 8, comma negative 2, and 5 minus 3, 2, comma negative 2. So that would be our vertices. Co-vertices. Co-vertices will be, again, we first account for the center. Our co-vertices will be along y. And since since b squared is 4, so b is 2. So that is plus or minus 2. And that implies that we have 5, comma, minus 2 plus 2, 0, and 5, comma, negative 2, negative 2. That is negative 4. Foci. Again, we first write the center, and our c is plus or minus root 5, so I just need to do it here. So that implies that my foci is do we have 5 plus root 5, comma negative 2, and 5 minus root 5, comma negative 2. Very similar to what we had at time, but using different axes. Okay, now let's put all this together. Our vertices, 8, negative 2. That is when x is 8, that guy is negative 2 here. When x is 2, y is negative 2 here. So this is vertex, vertex. Co-vertices, we have 5, comma 0, 5, comma 0 here, then 5, comma negative 4 somewhere. So definitely our center will be here. See our center. So we have this. What of foci? 5 plus something that is more than 2 but less than 3. So that will be between 7 and 8. So here, negative 2, here, somewhere here. And then 5 minus something that is more than 2 but less than 3. So that is going to be somewhere here, and we have it. All right. So our ellipse, behave that way. This is our minor axis, and this is our major axis. So we say this is co-vertex. This is center. This is focus. This is focus. This is minor axis, and this is major axis. So, guys, that is all I have for you regarding um, ellipses. So you can pause the video and try to work on this problem on your own. So, guys, this is where I will be ending this video. And in my next video, I will be walking you through parabola and hyperbola. So till then, keep having fun with maths. Bye for now.